The various types of forces in nature can be grouped in four categories: gravitational, electromagnetic, strong nuclear, and weak nuclear. Let's begin with the gravitational force. The universal force of attraction which is acting between objects is known as the gravitational force. The gravitational force between any two bodies is proportional to the product of their masses and inversely proportional to the distance between them squared. Gravitational force extends infinitely far in the universe. Over and above the gravitational force, the particles may exert upon each other electromagnetic forces. If two particles having charges q1 and q2 are at rest with respect to the observer, the force between them is given by the following formula, which is very similar to the gravitational force. This is called Coulomb force and it acts along the line joining the particles. If Q1 and Q2 are of the same nature, that is both positive or both negative, the force is repulsive, otherwise it is attractive. This is the same force which is responsible for the attraction of small paper pieces when brought near a rubbed balloon. Also the atoms combine to form molecules due to the electromagnetic forces. Now, you might wonder that if electromagnetism is so strong, then what keeps multiple protons which are positively charged bound in the nucleus of an atom? For example, if both the electrons are removed from a helium atom, we get the bare nucleus of helium which is called an alpha particle. An alpha particle contains two protons and two neutrons. According to Coulomb's law, the proton will repel each other due to the Coulomb force and will try to break the nucleus. Then why does the Coulomb force fail to break the nucleus? This is because they are kept glued together with a force that is even stronger than electromagnetism, and this force is called the strong nuclear force. They are short ranged. Radioactivity and energy liberated from the nuclear fission and fusion result from strong nuclear forces. Now, one of the important process in the nature is beta decay of neutron. A neutron can change itself into a proton and simultaneously emit an electron and a particle called antineutrino. This is called beta minus decay. Proton can also change into neutron and simultaneously emit a positron and a neutrino. This is called beta plus decay. This process is also important in making larger atoms stable. The forces responsible for these changes are called weak nuclear forces. The range of weak nuclear forces is very small, in fact, much smaller than the size of a proton or a neutron.